Bah! I forgot to unmute myself! This is frustrating! Okay, listen. So, I figured out the problem. I finally figured out why this is happening. So, I was using my iPad because I thought if I use my iPad, it'd be easier for me to explain to you guys, right? Kayak Ollie dari tadi itu sebenarnya pakai iPad gitu kan ya, right? And I think because I connected my iPad to the OBS, I think that's causing problems and causing bugs. I don't know why though. But I think that's the reason, because right now I'm using Paint and everything is smooth sailing from here. So I think we'll be studying with Paint instead of an iPad instead. Yeah. Can you guys hear me? Kedengeran? This whole time, yes, I think this whole time is the iPad's fault. Kayaknya akhir-akhir ini, kenapa kita dari kemarin selalu lagging? Pasti karena iPad. I think it's always because of iPad. It's not because of my internet. It's not because of YouTube. It's because of my damn iPad. Gitu. Jadi ternyata dari kemarin itu gak bisa karena iPadnya Ollie. Gitu. I don't know why. Gak ngerti mengapa gitu. Oh, Drizzer hates Wi-Fi. Anyways, finally, let me do my opening. Just one more time. Ollie opening bentar ya. Zomawa, subakawa, zombie idol. Crazy. Ollie desu. Everybody, welcome to the stream. Selamat datang ke streamnya Ori no Haishin de Yokuso. After so long, we're finally streaming maths. Setelah sekian lama, akhirnya kita belajar matematika juga. Tsuini kita yo. Sugaku no 配信。はい、今日はね、linear algebra を勉強したいと思います。So today we'll be studying linear algebra. Hari ini kita akan belajar apa sih? Linear algebra. Betul. Let me spell it out for you guys. And excuse the handwriting because I'm using a paint. Yay, math. I've never done math before. What do you mean you've never done math before? Kevin, you're a game developer. You need maths, vectors, and if anything, matrices to make games. What do you mean? Not to mention, you're using linear algebra. What? Okay, so linear algebra. Ollie, I'm hiding in a bathroom, skipping work, watching you. Let's go. Don't tell my boss, especially don't tell Mama Ina. No. Go to work. Go to work. If you have time to watch my stream, then you have time to work. Go. There's always the archive. You don't need to worry because we're not lagging anymore. Okay? Okay, kalau gitu. What bra? Algebra. The best kind of bra, the coolest bra ever. Yes, Ciku Ollie baik orangnya ya, tentu saja. Okay, so let me explain to you guys what linear algebra is. Ollie akan menjelaskan sedikit tentang apa itu linear algebra ya. Jadi aljabar itu, kita mulai dari aljabar ya. We're going to start from algebra. So algebra is. 本当にいいの? ありがとう. Thank you so much for the really nice super chat, big super chat. Thank you. Yeah, I'm going to say it again. Aljabar itu adalah ilmu di mana kita mencari tahu atau kita mengeksplorasi, itu dia katanya, hubungan antara bilangan-bilangan yang tidak diketahui. So basically, algebra is when you try to look for the value of a certain variable that you don't know yet. For example, okay? Let's say we have x plus y kuadrat equals x kuadrat plus 2xy plus y quadrat. So you don't really need to know the value of x or y to actually solve this equation, right? Sebenarnya kita gak perlu tahu x dan y itu nilainya itu berapa, ya gak? Gak perlu tahu untuk menyelesaikan permasalahan ini, oke? Nah sekarang kita balik lagi ya. Kan tadi kita udah tahu aljabar itu apa. Sekarang kita akan cari tahu apa itu linear. We already know what algebra is. So let's actually take a quick dive to linear. Jadi linear itu berarti kita bekerja dengan persamaan aljabar yang linear atau yang line-like relationship. So basically, when we come across linear, basically it has the word line right here. That means we're going to have a lot of relationships, a lot of interactions between one line and another. Begitu. Dan Ollie ingin Ollie ingin mencontohkan. I want to give you guys an example because sometimes if people see like x's or y's, or if they see any variable in a certain equation, they'd be like, oh my gosh, this is linear algebra. No, it's different. So let's say
本当にいいの？ありがとう。
Thank you so much for the big super chat again. Thank you. It means a lot. I'll try my best to teach. So anyways, let's say we have x plus y quadrat. I don't know what square, right? X plus y square. If we have x plus y square, this is algebra, but this is not linear. Ini tuh apa tuh namanya? Ini benar aljabar. Cuman ini itu bukan linear. Mengapa? Karena di sini nggak ada hubungan antara satu garis dengan garis yang lain. Oke? Berbeda. If you guys want to example of what a linear looks like, basically it looks something like this. Yeah. So it's not combined because if we have this, basically we're combining two numbers together. Soalnya kalau yang ini secara umumnya ini kita menggabungkan dua nominal menjadi satu gitu kan ya. Sementara kalau yang di bawah ini kita gimana ya? Ini ada relationship-nya gitu loh. There's a relationship between 2 and x and 2 with y. You know, if that makes sense. Basically. Jadi untuk singkatnya, linear aljabar itu adalah satu bidang matematika yang mengutilisasikan matriks. Okay? Kalian ingat matriks? Do you guys remember matrix? So basically, linear algebra is a knowledge where you utilize matrices. Remember matrix? Kalian ingat matrix kan ya? Kalau nggak salah terakhir kali kita ada math stream kita bicarain matrix. The last time we had a math stream, we were also talking about matrix. Ya. Jadi kalau kalian mikir, linear aljabar sama matriks itu dua bidang yang berbeda. Bukan. Matriks itu matriks dan linear aljabar itu memakai matriks. So if you think that, linear algebra and matrix, they're two different things. Not quite. I mean, they are different. But the thing is, matrix is matrix, while linear algebra, you use matrix to do linear algebra. Get it? Ngerti? Okay, so basically, the whole thing about linear is that you're dealing with a line-like relationship, right? Jadi untuk linear aljabar, itu pastinya kita mencoba melihat korelasi antara dua garis gitu kan ya. Think of it like this. If you guys are getting confused, linear algebra. If you guys are still confused to what linear algebra is, basically this is when Matsuri Senpai and I meet and have a relationship. When two lines meet together, there are no curves at all. Nggak ada kurvanya ya. Ini saat dua garis bertemu aja. Kita bilangnya gitu aja. Dimengerti? Okay. Easy peasy lemon squeezy. So, the whole thing about linear having a line-like relationship is already correct, but the relationships aren't between lines themselves, but rather between the variables. For example, let's say what example should I take? Light sticks and hoodies, yeah, merchandises. Let's say 3 light sticks plus 2 hoodies is, let's say, I don't know, $100. Okay, let's say that 3 light sticks and 2 hoodies are $100. So if we have this, then how much is 2 light sticks plus 1 hoodie? This is usually where linear algebra takes in, you know? Dan di sini biasanya linear algebra masuk gitu. So those relationships are represented with lines because they are linear. Dan ini semua diwakilkan oleh garis karena ini adalah linear. Okay? So basically, it means that there's no changes in the gradient or the slope along it if we get technical. Okay?
Thank you.
Moving on. Kita lanjut. Ollie kasih contoh lagi ya. So, a very simple way of thinking linear algebra is, let's say, again, we're going with the light sticks and hoodies. Let's say we have 4 light sticks, and we have 2 hoodies. And they cost around, let's say, they cost $16. Yeah. And then we have 3 light sticks, plus just 1 hoodie. And they cost $13. Now, if we want to write this down as matrix and vectors, basically, you gotta categorize them. You see these L's? The L stands for light stick. We can just put them here because they're 2 different things. And the value, or like the whole total, is going to be 16 and 13, right? We can just put them here. Okay? And then if we want to write down these, let's say this is the first time I'm buying merch. And this is the second time I'm buying merch. This is on the HoloFest second. Well, this is the HoloFest first. So we can write this down like this. 4, 2, and then on the second trip, 3 and 1. So this is a matrix. Well, these are vectors.
Sombra, thank you.
Does it make sense? Does it make sense? Did you have to use matrices, Ollie? Yeah, so... Alright, I haven't explained to you guys, huh? A lot of you guys might be thinking, yo, Ollie, why the heck do we need to learn linear algebra? Ollie, buat apa sih kita belajar linear algebra? Itu mereka nggak ada gunanya. So let me actually tell you guys the purpose. Let me motivate you guys a little bit before we get into the good stuff. Purpose of linear algebra. Okay, so kalau untuk penerapan aljabar linear ya di dunia nyata secara umum udah benar. Tapi ini Ollie kasih beberapa catatan aja biar kalian ada bayangan lah ya. Jadi kalian tahu yang namanya machine learning nggak? Do you guys know what machine learning is? Jadi basically ya, mesin yang kita maksud ini komputer ya. The machine that wait, this is propose, not purpose. Ollie, what the heck? Sorry. It's 10 p.m. Purpose. Wow. Okay. That's something. I'm very sorry about that. It's the purpose of linear algebra, not propose. Mohon maaf. Bukan proposal. Kebiasaan emang, it's a habit. I'm sorry. No way I'm gonna use this in the future. You need this definitely. No, actually, listen. We actually use this a lot in daily lives. We do. Especially those who actually take computer science. Di sini ada yang jurusannya computer science kah? Bagi kalian yang ikut computer science, pasti kalian udah pernah ketemu lah sama ini di semester 1, 2. 1 atau 2 ya? Atau 2, 3? Lupa Ollie. Anyways, machine learning is like a type of artificial intelligence that allows a software application to become more accurate at predicting outcomes without being explicitly programmed to do so. So, machine learning algorithms use historical data as input to predict new output values. So, why is linear algebra important in machine learning? Terus, maksud Ollie, apa pentingnya linear algebra di machine learning? Ya karena kita kalau lihat di atas, kalau machine learning itu pakai historical data sebagai input dia, dan historical data ini bisa dengan mudah direpresentasikan sebagai matriks gitu. Jadi penggunaan algebra linear ini bisa juga untuk pemodelan numerik. Disebutnya metode elemen hingga finite, how do you pronounce it again? Element method dalam bahasa Inggris ya. Untuk bidang-bidang teknik sebagai teknik sipil atau teknik mesin juga. Tapi yang ini ya begitulah. Ini pokoknya banyak. Ini kayak bawang, banyak yang harus kita kelupas. Tapi pokoknya begitu. Penggunaannya itu sangat penting di kehidupan kita. Kalau kalian mikir, aduh, emang linear algebra sepenting apa sih? Kalian mikir-mikir aja. Kita di dunia ini ada lebih dari 7 triliun ya. 7 triliun manusia yang sedang hidup. There's about like 7 billion, right? Or was it 7 trillion? Like a lot of people live in this planet. And we want to make sure, if we ever get to world hunger, let's say, okay? Or let's say we ever get to world extinction. What's the best method and how do we distribute food? How do we send help? And what's the most efficient way to do it? You can use linear algebra and your problems will be solved. It's pretty cool, basically. To put it simply, it's not very accurate. Yeah. Yeah, it's like, optimization. That's the word I'm looking for. And for math teachers, if I'm doing this wrong, I'm very sorry. I'm an English teacher, not really a math teacher. I'm just trying my best. Okay, so far, any questions before we move on? That was the definition of linear algebra. Yang barusan adalah definisi linear algebra. Apakah ada pertanyaan? Clear? Move on? No miss. Okay. Okay. Then, I'll tell you something. Let's review a little bit. So linear algebra, basically we're talking about line-like relationships, right? And what's a line in math? That's right, vectors. Kayak kalau kita bicarakan tentang korelasi antara dua garis, berarti kita membicarakan vektor kan ya? Apakah kalian tahu vektor itu apa? Vector. Going in both directions and magnitude. Oh yeah! Not that vector. But anyways, yes, a vector. Vector is basically something that moves around in space, whether it's physical or in computer science, data. Jadi kalau vektor itu adalah sesuatu yang bergerak di suatu space gitu loh. Mau itu space-nya seperti fisikal gitu, kayak kita gerak dari satu titik ke titik yang lain gitu. Atau enggak, ini jadi data. Bisa jadi data ya kalau di computer science. Yes. And how do I explain vector actually? To be honest, anything can be a vector. Like, you guys know how vector is when we're talking about movements, right? Kalian ngerti kan kalau Ollie bilang, oh vektor itu adalah pergerakan di space, di mana kita bergerak dari satu titik ke tempat lain, kan tinggal kayak gini kan ya. Ceritanya ini titik A, ini titik B, terus habis itu kita bikin garis, ya udah vektor gitu. Ini R, vektor. Ya basically it's like an arrow, right? Gampangan ya? Paham? Tapi ada vektor juga bisa dipakai untuk melihat data. Kayak vektornya itu nanti dijadiin matriks gitu loh. You can use vector to actually put data in. You turn it into matrix, yeah. Let's take for example Ollie. Ollie is 102 centimeters tall. Ollie's age is 17. And Ollie's foot size is 38. This itself, this is data, right? And it instantly turned into a vector while you look at that. As easy as pie. If for Ollie short, I'm not that short. I'm one of the tall girls in Hololive. Shut up. Okay. So vectors can be something where you move something physically, or when you it can also be a movement in data. I hope I got that clear. Now, next thing that I want to tell you guys about vector is that vector have two rules. Vektor itu punya dua peraturan ya, dua prinsip. Ollie nggak tahu kalau bahasa Indonesianya apa. Punya two rules. So vector has the addition rules. Addition. And it also has the multiplication. Multiplication by scalar. Jadi scalar. Jadi kalau di vektor itu kita bisa ada penambahan dan pengurangan apa sih? Addition itu apa sih? Penambahan dan pengurangan, dan ada juga perkalian antara memakai skalar. Mungkin kalian mikir, gila Ollie, ini apa lagi? Ollie, what the heck is a multiplication by scalar? Don't worry. It's a big word, multiplication by scalar, but I promise you, it's the easiest thing that you guys will ever study. This is the easiest part about vector. Mungkin kalian takut, Ollie, ini apa sih? Peraturannya aku gak ngerti. Pakai bahasa Indonesia apa? Gak apa-apa, gampang kok. Ollie jelasin ya. Let's start with let's move vector real quick. Let's get rid of this. Get rid of that. Okay, now I'm going to start using the lines. Shapes. Okay, so let's make a little vector. Okay, kita bikin vektor ya. Look at this little guy. We'll call him R. This little guy is a vector. Okay? And what do you know? This little vector has a friend. Has a friend right here. Well, hello there. What's your name? Let's call you S. Yeah. And what do you know? S and R, they want to meet up with each other. Wah, ternyata si R sama si S ini, mereka janjian pengen ketemuan, mereka pengen buka bareng gitu. So, what do? Well, you just pull a little line over here, and they'll meet up. They'll meet up in this nice place, right here. And this will be the time, and this will be the effort that they put to actually meet up with each other. We'll call this R plus S. Yeah. Some time. Okay? I wonder if I'm explaining this as easy as possible. Yeah, they meet at the center. Yeah. My OTP. Yeah. So this is basically addition, okay? And it doesn't matter how you draw it basically. Dan ini cara gambarnya pun bagaimanapun oke aja sih. Let's say you want to draw S first, then you want to draw let's say you want to draw S first, and then you want to draw R. Oh, goodness. Yeah. Like this. This is basically the R. This is basically the additions of vector. Am I explaining this correctly? Addition. Wait, no. Oh yeah. Wait, I'm drawing this wrong. Wait, no, wait, I'm drawing this wrong. I'm drawing this wrong. I was like, huh, this looks weird. I'm very sorry. Let's do that again. Let's do that again. Okay, so let's draw R first. Okay, we draw R. We draw R first. I'm sorry. Give me a break. I teach people grammar, okay? I teach people simple present tense. Give me a break. Let's say it's like this. And then they meet up over here. Yeah, there we go. There we go. That's what I wanted to do. Like that. Seperti ini. This is addition. Nice line art.
Sebaca, thank you.
Actually, wait. The arrows are wrong. Itu Ollie salah gambar. Wait. It's not supposed to go that way. It's supposed to go this way. Yeah, this is it. This is it. There we go. Ah. So this is the addition. Basically, how do I explain this? Basically, addition is when you go, is when you're taking a, yung mana ya? Is when you meet in the middle of a journey. For example, you go here, and you know, if this was your starting point, then you can just pull a line over here.
Sebaca, thank you.
And it'll be an addition of the vectors. Yeah. It's like walking along the path. And after you make a path, you go back to the starting line and you try to find the most effective way to go there. Okay. Cool. And then next we have a... Can we move on? Does everybody understand? Does everybody understand? Help, I can't understand. I'm sorry. Let's do this again. Let's try this again. The addition of vectors. Kita mulai lagi. Someone didn't understand.
Sebaca, thank you.
I am responsible because I drew the lines wrong. So let's say that there's a vector. Right here. This vector is going up. This man is going on a walk. And then suddenly this man said, oh, I'm not supposed to go there. I'm supposed to go here. And so the man arrives at this point, while the man starts here. Now, if you want to add up the whole journey, then all you need to do is that you pull this over. Because R and S. No, because well, this is like the whole journey, right? So all you need to do is that you count the journey that the man already took. So it's basically a R plus S, if that makes sense. It's not a shortcut. It's just you just add them together. Jadi ini kayak cuma ditambah aja gitu loh. Pung, pung, you add them together. And it becomes R plus S. But this is how we draw the vector. Yeah. Is R plus S equals S plus R? Why, yes, it is. For example, let's make another line. Contohnya. Let's say we make another line here. So basically, this line is the same as this one, right? It just goes here. And let's say we make another line. We make another line and it goes like this. Ini kan sejajar kan ya? S yang ini sama S yang ini kan sejajar. Dan R yang ini juga sama R yang ini, mereka juga sejajar. So like, they're the same length, basically. And this is called the associative personality, apa sih? Sifat asosiatif dari vektor ya. Yeah. So it doesn't matter if it's S plus R, or if it's R plus S, or if you want to add 0 plus S plus R. To be honest, this doesn't make any sense. You don't need to put 0 in anything, but basically it's the same thing. Yeah. Well, to be honest, yeah, commutative. Wait, not associative, commutative. Commutative. And I'm drawing the arrows wrong again. No, Lisalcom, but it's supposed to be like this. Sorry. Yeah, like this. From this side to this side, because when you draw it the opposite side from this side to this side, then it becomes minus. I'm very sorry. Yeah. You guys are already doing good. Why do you guys keep asking me to teach you maths? You guys are actually already correcting me. Buat apa kalian minta Ollie ngajarin kalian matematika kalau kalian sekarang yang ngajarin Ollie? Okay, next is a multiplication by scalar. By a scalar. Alright, multiplication by scalar is actually a lot easier than addition. So let's say this is our starting point. Boop. Ini titik awalnya kita ya. And let's say we make a little vector. Hello, Mr. R. If we want to multiply R with 2, let's say we want to make a 2R. Then all we need to do is make 2 of these vectors. So it becomes this. And this is the length of 2R. Yeah. And let's say you want to make like, let me actually get rid of this. This is the length of 2R, 1, 2. You just multiply it and it becomes longer. Or let's say you want to multiply R with, I don't know, a quarter. You want to multiply R with a quarter, then all you need to do is draw the line until here. Yeah, around this part. Get it? Let's say you want to multiply R with minus numbers. Like, let's say you want to multiply R with minus 3. Minus 3R. So what you want to do is that instead of going to the right, you go back. Because, you know, this is positive, right? Because it's positive, you're bouncing 2 places. But since this is negative, then that means you're going back 3 spaces with the vector. So we get 1, 2, 3. 1, 2, 3. And this is minus a 3 vector. Does it make sense? Bisa dimengerti? Easy, right? Oh, okay, that's an easy one. It's easy, right? Yeah. Okay, so I've been talking about associative a lot, and I got it wrong. It's not the last thing we were talking about. It was like commutative, right? It's not associative. Now I'm going to teach you guys about associative. So let's say we have a line over here. Let's name these lines. We're going to name this line, let's see. We're going to name you Y. And let's name this line X. Okay? So let's say that we make another vector. Let's meet up with Mr. R. Hello, Mr. R. Yeah, here's Mr. R. And Mr. R is located at, let's say, floor 2. You guys remember this, right? These are called coordinates. Remember coordinates? Like the ones with like the ones with lots of squares that you usually see. So like this is 1, this is 2, this is 3, this is 4. And the height is like 2. Like it's 4x and 2y, so it's like... Yeah, remember coordinates? Very easy, very easy. So we have Mr. R right here. Then let's say we wanna make Mr. S. Let's meet up with Mr. S. The same vector as before. And you know, because this is a coordinate, if we go to the left, that means it's going to be minus, right? So let's say that this is a -2, 1. Because, you know, this is higher, this is lower. Let's just imagine this as -2 and 1. -2 x and 1 y. Yeah. And you know, we're going to do some additions. S and R, they want to meet up with each other again. So we just pull some strings here and there. We're going to meet up at the middle. Yeah, we're going to meet up at the very, very middle. Over here. Is that visible? They want to meet up in the middle, right here. Right? So basically, we just pull another Mr. S. It's like the same thing. They're meeting up in the middle. And all we need to do is that we add them all together. So, additions. Basically, this is R plus S, right? R being 4, 2. And S being... Just a moment. And S being -2 and 1. So, this right here is going to be 2 and 3. Like the length of the x will be 2 and the height of the y will be 3. Oh. Understandable? Yeah. And this is called associative. Doesn't matter if it's SR or RS. Cool. Now we're going to do something a little bit tricky. We're going to try and do multiplication by scalar. Let's make another y. And then let's make another x. Kita bikin y sama x ya. Okay, there we go. This is y. This is x. Let's say that we have another Mr. R. Kita bilang aja kita ada Mr. R lagi ya. This is Mr. R. And let's say that Mr. R is let's see, 3 and 2. Kita bilang si R ini 3 dan 2 ya. Panjangnya 3 dan tingginya itu 2. So like the length is 3 and it's like x is 3 and 2 is y. Yeah. Let's say that we want to multiply this. We want to multiply the R. So what happens is that we draw another vector. We draw another Mr. R. How much will we have over here? Well, that's simple. Because all you need to do is just multiply by 2. And then you'll get 6 and 4. Easy peasy, lemon squeezy. And let's say you wanna let's say you wanna multiply it by minus, it'll become minus r. And all you need to do is that you turn all of this into minus. It becomes minus 3 and minus 2. So we're going to go back from the original point.
Thank you.
It becomes something like this. Understandable? Let's meet up again with Mr. S. We have Mr. S right here. And as you can see, Mr. S is going this way. Right? Mr. S is going this way. And Mr. S, let's say it has the... How much was Mr. S again? Was it in 2 and 1? Minus 2. And 1. Okay. This is Mr. S right here. Let's say that Mr. S has like an evil twin. An evil twin that doesn't, that really hates Mr. S. Like, it'll be Mr. S minus. Then what'll happen is that it'll go something like this. And S will also be minus. When it turns minus, all you need to do is multiply this with minus. So it becomes positive 2 minus 1. And let's say Mr. Positive R wants to meet up with the evil twin. Consult with the Mr. Minus S. All you need to do is draw a line like this. They'll meet up at this point, and all you need to do is add them together. So it becomes R plus minus S, which is 3, 2 plus 2 minus 1. Right? This becomes 5, and this becomes just 1. So the length is 5. It goes here. So it's like a... Wait, right? So this is 3. We just pull it over here, and they'll meet up over here. You see? It's like the middle point. Yeah. 5 and 1. Wakarimashita ka? I got it. Oh, it's easy. You're going to meet up over here. Yeah, the middle point. I gave you a 5 on rate, my professor. Wait, 5? 5 out of 100? Thank you. Oh god, what did I just see? The horror. What do you mean? This is simple. Now I'm going to tell you guys about the length of a vector and this magical thing called a dot project. Meh. So, let's meet up. Let's make another equation. So, this is going to be y. This is going to be x. Let's meet up again with Mr. R because Mr. R is our best boy. Mr. R right here in the house. Hello. This is Mr. R. Yes. So, let's say we want to project something. R is basically, okay? If we think about it, let's make a variable. The variable can be anything, actually. You can write it as x, or you can write it as literally anything. Let's write it as a. R is basically ax. Like, this is a variable right here. Plus by. Right? So basically, this is this. Right? Now from here, we actually want to know the length, and also where it's going. We want to know the dot product of Mr. R. So how do we actually get there, Ollie Sensei? Well, that's easy. We just use Pythagoras. Kita pakai Pythagoras di sini. Yeah. So let's actually draw a line over here. Boop, boop, boop. Like a fading line. Boop, 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 boop. And from here, we got ourselves a little triangle. Wow, you look at that. And what do you do with the triangle? Well, first off, we know that this part of the triangle is R, right? And since the height is going to be y, then this is y. We can call this like the by. Because this is going to be a variable, right? We don't know the length of it, or we can just write it as like length y. And then there's going to be ax, a as the variable, or we can always write it as length a. Now, how do you actually find the length of r? You just use simple Pythagoras. So, as we know from this picture right here, let me move this real quick. This will turn into a triangle like this, right? So this is A, this is B, and this is going to be the length of R. How do you find it? Well, through Pythagoras. So we're going to make a root A squared plus B squared. Easy peasy lemon squeezy. Why is that? Well, it's because R equals the vector A and B. Understood? Yeah. And so, well, now we know how to find the length of R. The next thing we want to know is how to define the dot product, which is one way of several of multiplying two vectors together. For example, let me make a new equation. Delete this. Maybe right here. Let's not make it too big. Trying my best here. This is going to be Y. This is going to be X. Okay, let's meet up with Mr. R. Again. Never get bored of Mr. R. Mr. R is our one and only savior. So this is Mr. R. Again. Mr. R is currently right over here. Let's say that this is tree 2. And as we demonstrated before, basically, this is AX and BY, right? Or we can, or to make it easier, we can actually write it down as RX and RY. This is Mr. R's attributes. Now we're going to meet up with another friend, Mr. S, as per usual. So this is S. Ugh, ugly looking S. Ugh. What have you been drinking, Mr. S? Mr. S attribute, let's say it's -1 and 2. And we write this down as SX and XY. Because the length of the X is -1 and it's 2 when it comes to the tallness. Right? Now, again, we're trying to find the dot product, right? So what we want to do is that we want to multiply the two vectors together. So what we do is that we get R and S together. And when we get R and S together, that means we're multiplying these two vectors, right? So this becomes RX times sx plus ry times sy. Okay. So then we'll have 3 times minus 1 plus 2 times 2. Becomes 1. Remember, this is r times by s. It can also be written as s times r. Doesn't really matter. Understood?
Thank you.
This is called the commutative. The commutative, right? Not associative. The commutative. Yeah, and the vector becomes it becomes minus 3 and 4. And this is the dot project. Commutative. Now this is commutative. Next thing I want to teach you guys is the distributive. Let's say we have another friend. Let's meet up with a new friend. S and R, they're good friends, but they feel lonely if it's just the two of them, so they invite a new friend. Let's call T. Mr. T. Oh, Mr. T. Yeah, so if we wanna get the dot product from this one, we still need to multiply. And how we do that is we, first of all, since S and T, they're on the same, how do I say it, line, kind of. It basically becomes R plus S. No, it's not plus. R times S plus T. And when we get R times S plus T, we get this. Which is like ini cuma diperpanjang aja. Apa difaktorisasi? Bukan faktorisasi. Jumlahin. Iya. RT. Okay. And we've talked about how R equals to Rx and Ry, right? So basically, R can be like R1, R2, yada 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 yada, until R infinity to whatever number it is. And the same thing goes to S and T. This is S1, this is S2, yada yada yada. Onwards, and the same goes to T. T1, T2, yada yada yada, T infinity. Right? And from here, we can write it down as because we know that basically this is what the RSTs look like. If we're going to gimana ya? Gue bakal dijumlahin lagi jadi R1 dikali sama S1 ditambah R1 dikali sama T1 ditambah sama R2 dikali S2 ditambah R3 kok R3 tiba-tiba R2 dikali sama T2 dan seterusnya. It goes onwards. And we can just simplify it as R plus S, R times S with R times T. Basically this. This is just me proving that this is this and this applies to this. If that makes sense. Yeah. This is the distributive sifat of vectors. Yeah. Now let's say we want to We want to find the dot product using scalar. Like there's suddenly scalar in here. Like let's say S gets multiplied by A. Bilang aja ini tiba-tiba S ketemu sama scalar gitu. Ketemu sama scalar terus akhirnya dia kena multiplikasi. All you need to do to actually and let's say that T never existed. Kita bilang kita ilangin T ya. Let's get rid of T. We got rid of T and suddenly S got an upgrade and it has a scalar now. This variable can be anything. It can be 2, 3, 4, 5, whatever number you want. So how do we count this? Well, we count it the same way we counted the past one. With the T. So it's R. We just multiply R with AS. Understood? And when it becomes R multiplied by the scalar S, the AS, it becomes something like this. Basically, it doesn't matter because everything will get multiplied anyways. And we can write it down as, if you guys want to see the long run, it becomes something like Rx multiplied by ASX plus RY ASY equals A multiplied by Rx multiplied by times by Sx plus Ry times Sy. So this is called the associative over scalar multiplication. Oh, Rainy! Ini stream bahasa apa lagi? Rainy, welcome! We're just talking about how to look for dot projectors and vectors by using the associative over the scalar multiplication. Hello, Rainy. Welcome to the stream. Everybody give it up for Rainy, my genmate from Hololive Indonesia Generation 2. She's a Monopoly master. It was her first time playing Monopoly today and she won. It's pretty easy, right? Yeah. I don't know, but it feels like they make algebra different. Well, you can blame algorithm for that. I think I get it. Good! Because next up, we're going to study about the cosine and dot products. Berikutnya kita akan belajar tentang cosinus dan dot product. Cosine dot product. Yeah. So let's make a little triangle, okay? Make a little triangle. We're going to name this side Mrs. A. We're going to name this side Mr. B. And then we'll get a C. Over here. Yeah. Actually, no. No, we don't make a triangle. We make vectors. That's what I wanted to say. I was like, wait, Ollie, what are you saying? No. We're meeting up with Mr. R and Mr. S again. There we go. I felt like something was wrong. So let's say this is Mr. S going over here. And then Mr. R over here. And then all we need to do is change them. We're going to merge them together, make them a fusion of a triangle. I wonder if this is clear enough. Maybe I'll use the pencil. There we go. Yeah. And this right here is going to be R minus S. So this is going to be our A side. This is going to be our B side. And this is going to be our C side, which is R minus S. And we're going to make a theta right here. This is going to be the angle. And do you guys remember the rule of cosine? Kalian ingat gak peraturan cosinus? Peraturan cosinus itu C square equals A square plus B square minus 2AB angle with the theta. Yeah, here it is. This is the basic rule, right? Yeah, exactly! Wait, how did you know? Yeah, cosine is the adjacent and hypotenuse. Oh, that is correct! Huh? Yeah. So cosine is at how do you... We're going to do it like this. Adjacent and hypotenuse, which we're going to write as R, because I'm too lazy. Yeah. So let's say we want to look for the length of let's say that we want to look for the length of R minus S, which is actually just Mr. C right here. How do we look for the length of R minus S? Well, we just put the R and minus S into the cosinus rule, which is let's say that C. Well, since we have C right here, so C is basically the length of R minus S squared. With A right here, the A will be the length of the R squared, and then it's going to be plus B is going to be the length of S. The length of S minus 2 length R times length of S with cos theta. You just put it into the equation. It's simple. And then, we just break it down. So what we get is that since this is squared, we can write this as length R minus S multiplied by length R minus S, which will be equal to basically R multiplied by R minus SR minus SR again because it's R with R, then R with minus S, so it becomes minus S, and then minus S with 1R, which is, well, again, minus SR, and then plus S. Wait, minus, yeah, plus S. Right? Wait, tunggu, bentar. I think I got it wrong. Wait. Okay, no, let's do that again. So this, if we write it down, it's basically the length of R minus S multiplied by the length of R minus S. And if we try to multiply this becomes r times r, which is this and this. And then r times minus s, which becomes minus sr. Then minus sr times by r, which is another sr basically, times by minus s. No, actually plus s, right? So this is the length of r squared minus 2sr plus the length of s square. Yeah. And then this actually connects back to this thing. No, doesn't connect to that one. This right here, this connects to this thing. It connects back to this. So we just use the method of elimination. So I cross this out. And then after we cross that out, we cross this out. Right? And so basically, if you move this here, if we move if we move this there, so like no wait, how to explain this? All right, so this is this, right? And since we crossed out these from these, then basically this eliminates this and this eliminates this, and that means this is this, right? Right? And so, therefore, that means let's make like a little square over here. Therefore, that means minus 2SR equals, what did we had? Minus 2 times by the length of R times by the length of S and cos sin, right? Angle. And so we get we cross the minus 2 way, and we get R times S or S times R, whatever it is, equals the length of R multiplied by the length of S. Right? Is it correct? Is this how you do it? I forgot. Kayak gini kaya? Was it like this? Yeah, I got it right. Yay! I got it right. So this is the cosinus dot product formula. Yeah. Jadi ini adalah formula atau rumus untuk cosin dot product. Yatta ze! Yatta ze! Okay, so let's actually put in some real equations now. Terus sekarang mari kita taruh masalah beneran. So what was it again? It was, the formula was S times R equals the length of R times the length of S times the angle, right? The cos angle, the cosin. So let's say, mari kita bilang, we have this. Let's say we have this angle. So let's say that this thing is S, and let's say that this thing is R, and let's say that let's say that the angle here is 90 degrees. So basically, because the equation is because the formula is r times s equals the length of r times by the length of s and the angle, the cosine. We gotta determine the cosine, so the cos for 90 is going to be 0, right? So if you even if you multiply the length of r and the length of s, and the dot product is 0. Right? Is this right? Or let's get another line. Let's say we have the line of r right here. And we also have a line of s right above r. And because there is no angle at all, basically, the angle is non-existent and it's 0, right? So, if we count this in, that means it's r times s equals the length of r times by the length of s multiplied by the cos of 0. And the cos of 0, wait, that's a 9. And the cos of 0 is 1. So this is... yeah! Yeah! So, yeah! Or, let's say we have this vector. This is the r vector. And this is the s vector. And that means the whole angle is a whole 180. That means this is a cos 180, which is minus 1. That means r times s equals minus the length of r times by s. Yeah. Yeah. I think this makes sense. Yeah. I'm sorry, guys, but as confused as you guys are, I'm also very confused. I'm learning together with you guys. Nelly sambil belajar bareng kalian soalnya. The title is We'll Study Algebra, and I'll make sure of that. I'm not teaching you guys anything. We're just studying together. Ini Ollie nggak ngajarin kalian apa-apa ya. Ini kita belajar bareng aja. Hehehe. So now let's learn about projections. Sekarang mari kita belajar tentang proyeksi kali ya. Projections. So remember there's that one guy that said that the cosine was the adjacent divided by the hypotenuse. Yeah, basically adjacent divided by the length. Let's put length of A here. Right? So, what happened to the music? Oh, there we go. I thought the music disappeared. So, let's meet up with Mr. R again. We have Mr. R over here. And then let's meet up with Mr. S. Mr. S is over here. Oh, no. Okay. So let's say we have Mr. R, then we have Mr. S right over here. If we pull this down, then that means we can have a nice 90 degrees, also having a theta over here. So if you try to multiply S and R, then that's basically with the formula that we just discovered. And that means this is the length of R times by the length of S times by cos theta. And this is the adjacent. So basically, the cosine is the length of S cos theta divided by the length of R. Yeah, and if the theta, if this angle is like 0 degrees, no, not 0 degrees, 90 degrees, then that means there's no projection. Yeah, you see, this thing right here, I remember. This thing right here. This is called the projection. The S right here is projecting stuff. It's projecting a shadow. Or a light. Whatever you like. Right? This is the projection, and the projection is the adjacent. So, if we want to look for the dot product, basically, because this is the cosine, it's basically R times S divided by the length of R equals the length of S cos theta. Because this is the scalar projection from here. Yes. And if I want to encode which way R is going into the dot product or into the projection product, then all I need to do is I get these two in. I get them in, but we also multiply the length of R with another length of R, so that makes it length of R square. And this will become R times S divided by R times R. And they both will be timed by R2. Because that is the vector projection. Hence, which is why you use simple past tense, no, simple present tense, when you want to state a repeated action, facts or generalization, scheduled events in the near future, or tell what's happening right now but in a non-continuous verb. Basically, it's subject plus verb plus object. And if this is he, she, it, then we add an S behind the verb. If we want to use non-continuous verbs, then we use two B's. And remember, he, she, it uses the to be is, while the other I, you, we, they, we use a variety of am, and are. Also, we use has for he, she, it, and have for I, you, we, they. There will be adverb placements, and that will further explain when it takes place or what's happening. It'll give details on what comes next.
Thank you.
I thought this is a math stream. Why, Siska, hello! Would you care to learn simple present tense with me? For example, a little example of what a simple present tense. I study math. Notice how I instantly meets up with verb 1 and doesn't have any other suffix at the end. And we do not use two B's in the middle of I and study. It is not I am study math. It is not I is study math. It is I study math. We do not need the two B's in it. And if you're trying to point out at someone else, for example, let's say that we want to take the subject of he, then we just put S at the end of study. He studies math. And you know, if we want to make it negative, all we need to do is just put don't. And between the subject and verb 1. Same goes to he, she, it, but he, she, it is a very, very special case. Because when they turn into the negative, then we don't put he don't study. No, this is incorrect. We put he doesn't. Because that's just the law of English. And when we already have a he doesn't, then we don't need to put another S at behind of study. It's not he doesn't studies. No, it's he doesn't study. Yes! If you want to turn it into an interrogative sentence, then all you need to do is switch them around. Remember how we put the 2B of don't in the middle of a subject and verb 1? All we need to do if it turns into an interrogative is that we put it at the front. For example, do. We put it at the very front, then we put a subject right over here, you. And then we put the verb study. And also the object. Math. As simple as that. We use this also to state repeated actions. For example, for a good example, Siska will be our main subject. Okay, and Siska, mind you, Siska is not an I, Siska is not a you, because we don't know if you're really Siska. We're not talking directly to Siska. Siska is an individual, is not plural. It does not mean that Siska is us. It is not we. Siska does not belong in this category. Siska belongs in the category of he, she, it. Siska breathes because this is a repeated action, and because Siska falls into the category of he, she, it, we put an S at the end of it. Breathes. And then we put the object. The object being air. I'm okay. I'm okay. Japanese class win. You guys need to know the differences of when to use no, when to use to, when to use de, when to use ni. These are basic. Oh, also wa and ga. These are basic Japanese particles. You use no when you want to point out to possessive. It's a possessive particle. To is basically when you want to. It's a particle that you put right after something that's with you. A day is a place along with ni. I don't know the differences between them. Wa and ga is pretty similar too, but wa is more to is, and sometimes you use it for negatives. Well, ga, you use it for, I don't know. There's still a debate to how we use ha, wa, and ga. Also, did you guys know that sugar and protein, they are processed differently within our bodies? Do you guys ever wonder why bodybuilders go on a protein diet and not a sugar diet? Have you guys ever thought of that? Well, that's because sugar goes through 3 cycles. 3 cycles of digestion. Well, proteins only go through 2 cycles. Hence, it's a lot easier for our body to actually digest protein rather than sugar. Okay? Do you understand? We're studying math, mind you. Yes! Are you okay? I am definitely okay. What else? You want me to teach you linear algebra? I'll teach you linear algebra. Do you guys know Pablo Picasso's full name? Pablo Picasso's full name is Pablo Diego Jose Francisco Pablo Diego Jose Francisco de Paula Juan and Nepo Muceno. Pablo Diego Jose Francisco de Paula Juan Nepo Muceno Maria de los Remedios Cipriano de la Santísima Trinidad Ruiz with a Z like Picasso.
Thank you.
So that has been linear algebra. Yeah. You good now, Ollie? Oh, I'm good. I'm good. Where's Lopez? There's no Lopez in Pablo Picasso's name. Wait, let me try to memorize that. Right? This is correct, right? I didn't get anything wrong, right?
스파자 thank you.
Pablo, Diego, Jose, Francisco, De Paula, Juan, Nepomuceno, María de los Remedios, Cipriano de la Santísima, Trinidad, Luis, Picasso. Hi, というわけで来てくれて本当にありがとうございました。Thank you so much everyone for coming to this stream. Terima kasih banyak telah datang ke streamnya Ollie. Berikutnya Ollie akan membacakan donasi. Next up I'll be reading donations. So thank you so much everyone. Let's go. Hi. Who teaches JavaScript now? What do you take me for? An IT student? I don't study those. We're actually ending it here. Yeah. My head is starting to hurt. I'm starting to get sleepy. Mo. Matematika itu mudah dan menyenangkan, bukan? Bukan. Begitu. Class was very informative today, Ollie. Thank you. Thank you so much. Hi, yeah. We'll be reading some donations and then we'll be ending the stream. Hi. I learned that Pablo Protein class IR study math. No. Will there be any more math streams? I don't know. I rusted in math. I really did. I hope you guys enjoyed the stream. There was a lot of mistakes. Again, I'm not a math genius, okay? A lot of people take me as a math genius, but no, I just like studying math. Math is like the apex for me. I like it, but that doesn't mean that I'm good at it. Kayak banyak orang yang ngira Ollie itu jago banget sama matematika. Sebenarnya nggak juga sih. Matematika bagi Ollie itu bagikan apex. Ollie suka, seru. Cuman masalahnya ya bukan berarti Ollie jago dalam menerapkannya, dalam mengajarkannya, atau dalam mengaplikasikannya gitu. You like math for fun? Cool. Yeah, I like math for fun. It's not a tutor stream at all. It's just us trying to understand linear algebra. I don't know if I did well. Hopefully I did. So yeah, little disclaimer. I'm a math enthusiast. Yeah. Basically. If you like it, it's a strength. If it's not a strength, it will become one. I wanted to teach you guys about the eigenvalues and eigenvectors since that would be easier. But the thing is, I don't have my iPad with me and it'll be very hard to actually explain what those are. Because we're playing with drawings instead of countings when it comes to the eigen. Eigen is German for characteristics. If you guys don't know, it's part of the linear algebra. Could you get Gura interested in math? I mean... Oh, I don't know. Are you already teach about trigonometry? Trigonometry I'm not very good at, to be honest. I find linear algebra a lot more easier than trigonometry. Because I kinda... Yeah. Eigenvalues and eigenvectors are actually hard for me to understand. Well, to put it simply, eigenvalues is the value of a vector. Well, eigenvector is basically a vector that we've already turned into something else. Like, if we draw in our minds, like if you guys close your eyes for 1 second, and try to imagine the X and Y coordinates. Now imagine Mr. X and Mr. R and Mr. S again. They're at the same place as always. At Mr. R is at 3 and 2, while Mr. S is at -1, 2. Yeah, try imagining it in your head. Now, let's say that you have let's say that you can pull Mr. R and Mr. S upwards. Like, you know that trumpet boy? The one that goes teet, 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 teet. You can see the trumpet boy going up and down and going diagonal side to side. Like, we can see the trumpet boy transforming into different shapes and forms, into different sizes. Well, that is what we call the eigenvector. Basically, it changes. If something doesn't change, like let's say, you guys remember the trumpet boy? Like the trumpet boy, his feet didn't really move that much. The only thing that changed was probably the angle of his body, how high his head is, right? And from there, we measure the eigenvalue. That is called the eigenvectors and eigenvalue of a linear algebra. It's a completely different beast than counting the multiplications by scalar or getting the dot projects whatsoever. Yeah. Basically, that's it. What's our grade, Sensei? I don't know. I'm not a sensei. I'm also a student like you. Physics class with Kobo, man. She won't ever look at me as a senpai ever again. But anyways, time to read donations! First of all, I'll be reading from Super Chat. Super Chat. Okay. So, first of all, I'd like to say a very big thank you to Ghosty-chan! Matt, Ikuza, and Yuta better behave. And Fluent 60 FPS and muted Ollie. Yes, muted. Thank you for telling me. I hope you had fun and PC drawing tablet fun. Thank you so much for the donation, Ghosty-chan. Thank you. And the next is from Oji-san Howard. Math? No, my kryptonite. No, what do you mean? There's nothing wrong with your kryptonite. We're just counting. Not really counting. We're actually just making equations and whatnot. I'm trying to determine the vectors of Mr. R, the length of Mr. S, and whatnot. Thank you. Next is from Bobby. Ollie, linear algebra, let's go. Again, I'm not very good at it. Thank you. Ollie berarti anak IPA tapi IPS. Gimana? Anyways, thank you. Next is from Squiggly Mustache. Ollie, I'm hiding in the bathroom skipping work. No, don't ever skip work. Thank you so much for the pink super chat, but don't do that. You guys can always watch me whenever. There's always the archive. I just private streams that I find are not relevant to the channel. Yeah. Unless they're irrelevant or I got copyrighted. That's the only reason why I private my streams. Yeah. Thank you. And then next is from Mathron 5000. I'm skipping my actual linear algebra class to watch this. 100% worth it. What do you mean? Study real time. But I didn't teach you guys anything. I even got the first vectors wrong. I mean, we did kind of do well right after that, but I was wrong. Thank you. Next is from Squiggly Mustache again. You're right. I need support with money. Back to work. Thank you. Good luck with your work, Squiggly Mustache. Thank you so much for it. You basically gave me a red super chat. I appreciate it a lot. I'll put it to good use. And thank you. And then next is from Okami KFC. I want to thank you, Ollie, since I started to have interest in math because of you. And well, I'll start math college in 1 month. Wait, you actually? Wait, what are you majoring for? Ooh. Do you want to become a teacher, a math teacher too? Sounds cool! I'm glad I managed to inspire you to like maths. Makes me happy. It's like when people say, Ollie, because you're having fun in Apex, you inspire me to play Apex. It makes me super happy. Engineer? IT? Computer science? Congratulations! The next is from H. Ollie, my intelligences. Teach me how to matrix, please. We already covered matrix on our last math stream, I feel. But anyways, thank you. Next is from Viral. Izin boss, kelas ini bu, saya udah jago soalnya. Okay, bye-bye. Makasih. Thank you for coming. Viriel. Thank you. Next is from Red Baron, please. 2ab equals minus 3b. Oh, this one's easy. Look at the numbers. Yeah. Thank you. And the next is from Wiggles. Is this gonna be on the final, Ollie Sensei? Y'all, I don't even make exams. I just stream Apex and Minecraft on YouTube. You guys, don't expect much from me. I'm just a VTuber. An anime girl. Streaming her games on YouTube. What do you guys expect from me? Need I remind you? Thank you. And then next is from female Ghosty-chan. Propose of linear algebra. Please marry me. No, not propose, but purpose. Thank you. Next is from Shakuya. Oh, I caught the stream. Also wonderful to see that your magnificently long hair is looking well today too. You must have taken good care of it. And taken good care of it, I have. Thank you. So no homework. Not today. Thank you. And next is from Sai. It's not much, but PC tablet fancy ikuzo. Thank you. I'll look for some pen tablets that I can use. Thank you. Next is from Minori Sensei. Ollie teacher, sorry I was late. I'm standing in the hallway with a bucket. No. Sensei nara daijoubu yo. Haite. Arigatou gozaimashita. Thank you. And then from female Ghosty-chan. Can I have an S with R equals 18? What does that mean? But anyways, thank you. Next is from P2 the Rex. Ollie Sensei konbanwa. Sorry I'm late. The bus decided to have errors. Here's the onigiri for you, Sensei. I like onigiris. What's inside? Umeboshi? Umeboshi onigiri desu ka? Umeboshi ga chou suki yo, Ori. Thank you. And the next is from Sour Patch Armadillo. Thank you for getting people into really useful concepts that normally aren't very approachable. I tried my best. Hopefully I did good. Thank you. Next is from No9. Tasukaru-masu. Thank you. And then from Gogo Desika. You're doing the Lord's work. The Lord might be an evil math wizard, but still, I love you so much, Ollie Sensei. Thank you. I didn't do much though. I was fumbling all over the place. Next is from Fefe. Teacher, I was late for class. I'm gonna need you to start completely over from the beginning. Fefe, we'll have a private tutoring lesson after this then. Just the two of us, inside the classroom. You're in big trouble. You gotta see me after class, Fefe. Thank you. And then next is from Hiragi-san. 寝る前に YouTube 開いたらおりちゃんがすよすよ数学やってた線形代数 linear algebra は理解できると美しいけどラインが増えれば増えるほど忙しくて大変だよねおりちゃんおりこだよおりちゃんやっぱりおりちゃんは最高に賢いペタンゾンビだぜおやすみ When I opened YouTube before going to bed, Ollie was doing maths. It's beautiful to understand linear algebra, but the more lines you have, the busier and the harder it is. Yo, Ollie. After all, Ollie is as smart as a zombie. Good night. Good night. 来てくれてありがとう、ひらぎさん. Thank you. ありがとうございました. And then next is from Ghosty-chan. Sorry, Ollie. Ever since Theta, I have the opening from an 80s anime stuck in my head. I need to fill my head with Jolly Jolly again. Yeah, do that. Thank you. Next is from Couchy. Can R dot S ever be larger than the length of R times length of S? Or is there some sort of inequality about that? No. Because they're basically the same thing. Unless you're trying to look for the R dot S. If you're looking for the R dot S, then you gotta time the length of R with the length of S. Because R dot S does equal to the length of R times by the length of S. Right? Yeah. So I don't think one can be bigger than the other. I don't know if I'm correct. right? Oh, the length of R is value and R is a vector with X and Y. Oh, there we go. So it can be bigger, I'm presuming. The length of R dot the length of S is an absolute number. It's always positive. Well, R dot S can be either positive or negative. It's the same. It's the same or opposite. Oh, okay. So there you go. It can be bigger. It can be smaller. The R and S. The R dot S, not the length of R times the length of S. Yeah. Thank you. Next is from the great Billy Mays. Sorry, Miss O. I arrived to class late. Please don't overwhelm us with too much math and homework for the next class. Thank you. Oh, wait, this is grammar. Am I in the wrong classroom? No, I just had a mental breakdown. Thank you. And the next is from Female Ghosty-chan. I am in love with Ollie. Is this the correct grammar? Yes. It indeed is. Because I am in love with Ollie. You're doing a non-verb. It's like a non-continuous verb, you know? It's a non-continuous verb, but you're also stating what's happening right now. You are in love. That is correct. Thank you. Next is from Google. So this is what your grammar tutoring job is like. No, I don't scream while I tutor my students. But thank you. Next is from Shrimpy. Hi, Ollie Sensei. It is my friend's birthday tomorrow, and his name is Davon. Can you wish him a happy birthday? Davon! Happy birthday! Happy birthday! I hope you'll have a wonderful time. Your friend Shrimpy told you to Shrimpy told me to tell you a happy birthday. And I'm here to wish you the biggest, happiest birthday ever. May all your wishes come true. May you stay healthy this year too. Happy birthday, Davin! Your buddy Shrimpy here is a real friend. So be sure to celebrate and party together. Yeah! Happy birthday! Tanjobi omedetou! Thank you! Next is from Stormis. Will Ollie Sensei be teaching planar algebra too? I heard Ollie Sensei is good with flat planes. Shut up. But thank you! Next is from Yin Izuru. Ollie, are you okay? Do you need to talk? Monopoly and math hurt you? This is the kind of... That's getting crazier. This is fun though. Thanks, Senkir. Thank you! I'm okay. And the next is from Fateburn. Ollie Sensei, I want a baby. How make baby? Okay, let me tell you how to make babies. You guys ever heard of something called the ovaria? Ovaria is an egg that needs to be fertilized. You fertilize it with something called a sperm. But you see, the chances of the sperm getting into the ovaria, the ovum actually, it's pretty small, but also big at the same time, because inside one drop of sperm, there's like thousands and thousands of tails within it. Only one can actually get into the egg, actually. If you're lucky, you can get two. Yeah. Ollie, now what do you mean? It's science! It's science. I'm telling you how babies are made. I'm not telling you how to make it. Yeah. It's education! Can we clip this? I don't know if I'm saying ovaria and ovum right. I forgot which one is which. But basically, there's this egg inside of a woman's body, and you need to fertilize it by putting sperm inside of it. And once the sperm is inside of it, magic will automatically happen in your body, and a janin will start to be made. What am I trying to say? Ovum is inside the ovarium. Yes, correct. Yeah, it's baby magic. It's just pure science. Yeah, it is interesting. And you know what else is interesting? Have you guys ever heard of that disease, HIV? Yeah, if you're trying to make, if you're quote unquote trying to make babies with someone sketchy, if you're trying to make too many babies with too many people, then you might get HIV. It's a very deadly disease. It lowers your immune system, and you'll be a lot more prone to lots of other diseases. Yeah. And it even gets transmitted to the baby. You're right. AIDS. So that's another education fact for you guys. Or STD. And you will die. So there. Science is scary. And you know what else is scary? Irresponsible people. Yeah. Human immunodeficiency virus, right? Exactly, the HIV. So don't try to make too many babies with too many people, or don't try to make babies with sketchy people, because sketchy people, we don't know we don't know if they ever try to make babies with other people too. Okay. Next up, I'd like to say thank you to Gilsey-chan, continuing the sudden subject changes. Also, light is also a wave and a particle at the same friggin' time. How difficult is that to understand? That is actually correct. It is. And you know what else is cool? You can somehow bend it. I don't know how that happens. Thank you. Next is from Kokokorbis. Okay, now I'm ready for any algebra exam. Thank you, Ollie. You're welcome. And I want you to remember that Pablo Picasso's full name is Pablo Diego Jose Francisco de Paula Juan Nepomuceno Maria de los Remedios. I keep forgetting at the she part. Cipriano de la Santísima Trinidad Ruiz y Picasso. Okay, thank you. And the next is from Holy Fuzzy. Ollie Sensei, I want to learn 3D differentiation. Maybe another day. Thank you. And then from Bobby, Pat Zombie. Thank you. And then from the Gamer Creed, we're getting a whole semester worth of education all condensed into one stream. Yes. Thank you. And also, you're welcome. And then next is from... Wait, there's quite a lot of donations. Thank you so much, everyone. From the Snurlings. Here's some of my tuition fees. I do hope I can get unpaid internship after graduating from Ollie School of International Maths and Paint. Thank you, Ollie. You're welcome. Thank you. And then next is from Kevin. Okay, but for real, I didn't actually know that linear algebra is what I've been doing this whole time, right? I'm surprised how you don't know what linear algebra is. Because games in particular, or like if you're programming, you're basically doing linear algebra. Yeah, that's basically the foundation. You're playing with matrices and vectors. Especially since you're doing 3D and platform games. Yeah. Thank you. And then next is from Jalorda. Hey Ollie, thank you for the stream. I'm not good at math, but I try to improve my Japanese. Look, ore no desunatsu. God dang it! Love you and sorry. No. Besides, you spelled it desunatsu. It's not desunatsu. It's desunatsu. If you want to spell out these nuts in Japanese, you need to have a small I katakana right after the de. Then you get a these nuts. That's just a desunatsu, not a desunatsu. So another lesson here. Thank you. I'm so embarrassed. Why did I send that? All good. Oh, ore no desunatsu. Yeah. Thank you. Next is... Okay, thank you for the advice. You're welcome. Next is from Mud Arcade. I recommend trying Fortnite no build mode. It's fun. Thank you. I'll try to get into Fortnite, actually. A lot of people have been recommending me. My friends, especially. What's Among Us? Among Us is... Among Us. Among Us. Among Us. Basically, if you turn it into katakana. And the next is from Wolfie1012. Ollie, I've memorized a lot of math and numbers in my life, but can you teach me something I need to learn? I don't know your phone number. Ooh, smooth. Well, my phone number is 08 6969 420 420 314 and 555 666 with extra dip and a large soda. And that's my phone number. In case you don't remember. In case you don't know, yeah. That's what I want to say. And Gail, next is from Takeru. Arrived just in time for the end. I have a hard time catching you live, but I have been using your VODs to keep me entertained during a long day work. Here's a tribute for all of the live streams I missed. Thank you for everything. No! Thank you for the donation! That is a 69 pink super chat. Thank you, Takeru. Goodness. How many sandwiches can you buy with it? Thank you so much for actually coming. I'm sorry that my streams aren't the most friendly when it comes to the CST PST. I apologize. Next is from Jinaga Don Saram C. Thank you, Teacher Ollie. It was an informative class, and if you don't mind, could you provide a lecture of stereographic projection and symmetry and geometry? I'm struggling to understand. I am not a sensei, but I'll see what I can do. Thank you. Next is from Okami KFC. Y'all start to June bachelor's degree in mathematics in college. Good luck! Good luck, man! In mathematics. We're wishing you the best of luck, Okami. Thank you. Next is from Luth. Gonna be that one kid that everyone hasn't asked a question at the end of the class, but Ali Sensei, do we have homework today? No. No, not at all. Thank you. Next is from Namae wa? Your name is Kimi no na wa Ogura-san. Ogura-san, kawaii. Arigatou gozaimashita. いつも可愛いです。世界で一番可愛いゾンビアイドルクレイジーオリーと申します。どうぞよろしくお願いします。応援してくれてありがとうございました。Thank you. Next is from Glowcaster, the most enjoyable class I've had so far. Thank you. I'm glad you enjoyed it. Thank you. Next is from Dustin Rawlings. I heard hand holding has a risk of babies. Is this true? I'm worried. Not really, but hand holding has a risk of you actually getting COVID. You might want to social distance yourself, and don't forget to always sanitize your hands afterwards. We don't know where that hand goes because you're always touching your phone. Sometimes if you take a phone call, then your phone will stick to your face, and we don't know the chances of you getting sick, but it's better to be safe than sorry, right? So it does not have the risk of having babies, but it does risk your health. Yeah. Okay. Next is from Staple Duck. Mom, come pick me up from school. I'm scared. Thank you. That was a Mean Girls reference right there. I like it. Yeah. And then next, I'll be reading from Streamlabs. Let's see, Streamlabs. I think there were some donations from Streamlabs, right? Or was I mistaken? I was mistaken. There were no donations in Streamlabs. I think Sociabuzz? Yeah. So, So, from Sociabuzz, From Sociabuzz, I'd like to say thank you to Dr. Jude. Among Us! With a lot of S. Thank you, Dr. Jude, for the donation. Terima kasih banyak atas donasinya. And that's about it. That is all of the donations for today. Thank you so much everyone for coming to the stream. Terima kasih banyak telah datang ke streamnya Ollie. Kita kira honton ni arigatou gozaimashita. A little announcement before I end the stream. Sedikit pengumuman sebelum Ollie end stream. I won't be streaming at all tomorrow. I have a lot of work that I need to catch on. A lot of recordings I need to take. So, yeah. Tomorrow will be my day off, and I'll be back again with Hanako on Saturday. Yeah, dan nanti Ollie balik lagi Sabtu. Bukan Sabtu deng. No. I'll be back at Friday. Yeah, I'll be back at Friday. Nanti Ollie balik lagi hari Jumat. Until then, I'll be having a day off to work. Yeah. So thank you so much everyone for coming. Kita kira honton ni arigatou gozaimashita. Terima kasih banyak telah datang ke streamnya Ollie. This has been Crazy Ollie, and I am signing out. Pablo, Diego, Jose, Francisco, De Paula, John, Nepomuceno, María de los Remedios, Cipri, Ano de la Santísima Trinidad, Ruiz de Picasso.